Chydonns Academy, UNN. And as usual, we're here to give you the best and the premium educational content for your studies and your academics. And so today, we'll be taking a very wonderful, sweet topic in analytical chemistry. And the topic is nuclear magnetic resonance. And for some of us who be doing analytical chemistry for the first time, it's not all like departments that do it, but people who will be in the sciences a lot and in the engineering sciences, they also take part in this like particular concept, and it's a very interesting concept, but you just need to be able to get the basics around it. Once you know your basics, you can do anything. And it's really interesting because most of our drugs, most of the things that we get to use industrially, they are tested through these analytical techniques. So like we all know, analytical techniques are means of discovering or quantifying or qualifying the amount of a particular sample in your sample of interest. And in analytical chemistry, there are various and diverse analytical techniques. There is the classical techniques, the titration, the gravimetry, and now, as we are now in the 21st century, we are in a new set of techniques called the instrumental techniques, and these ones are diverse. So you can use your electrogravimetry, you can use chromatography, you can also use your spectrophotometry. And so NMR is a very sweet branch of spectrophotometry, where spectrometry specifically, where you get to use radio waves to detect the particular properties of a particular element. So I'll be holding this marker in my hand. We can see this marker, but because we all know it's a marker, it's common knowledge to us. But if we didn't know that this was a marker, what we have done, we need to look for investigative techniques to determine the content, the element that is in this particular marker, and other things that can make this marker what it is. Obviously, it has ink inside. So a very good way of doing this now would be to use the NMR. And the full meaning of NMR is called nuclear magnetic resonance. So we'll get straight to business. NMR is used to study a wide variety of nuclei. And now, when I talk about nuclei, I mean atomic nuclei. So we all know our periodic table. We know hydrogen, helium, lithium, all those things, beryllium, and then we go all the way to first 20 if you're in secondary school, and then they tell you first 30 if you're in university. Well, you can study the particular characters of this nuclei by NMR. So NMR is one means, there are different means, there are various means of studying nuclei, and you can use based on what you have on your electromagnetic spectrum, which is regularly your radio waves, infrared waves, your visible light, your ultraviolet rays, your UV rays, that's your ultraviolet rays, your X-rays, and then your gamma rays, with all these things. So you can use these different particular rays of different wavelengths to study different nuclei. You use your UV rays to study UV spectroscopy. You use your visible light to study visible light spectroscopy. You use IR to study IR spectroscopy. When it comes to NMR, what we use radio waves. So radio waves in the electromagnetic spectrum, they have the longest wavelength and the longest frequency. They're all around us. So the mere fact that you can pick up your phone and connect to your radio means that there are a lot of radio waves all around you. So we're going to get straight to business in this video. So follow me. NMR is a branch of analytical spectroscopy which uses radio waves. So note this. Number one, NMR uses radio frequency waves. I hope you can see my handwriting. And as we all know, these radio waves have a very long wavelength, a very low energy, and also a very high frequency. So the NMR machine is used to do just this. So NMR is concerned with the magnetic properties of certain atomic nuclei, majorly the 1H carbon, hydrogen, and the 13C carbon. So before we start with NMR, we would like to know what type of materials, what type of molecules can take part in an NMR study. To emphasize on this, only materials, only nuclei that have an integer as their spin quantum number can take part in NMR. So if you have 0 as a spin quantum number, you cannot take part in NMR. If any molecule or any nuclei has 0 as a spin quantum number, it cannot take part in NMR. If it had a negative fraction, right, it shouldn't be able to take part in NMR. But if it has a positive integer, it should be able to take part in NMR. So when we talk about things like let me get straight to business. Let me write some particular elements that can take that you can. We will now determine if they can take part in NMR or not. We have oxygen 16, oxygen 17, oxygen 18, and so these are like isotopes of the same elements with different like relative abundance. And so the most common one, as we all know, is oxygen 16, but there's also 17 and 18. So in this case, you'll be having 8, 8 is because, like we said, the atomic number is the same thing, but the mass number is different. So you're having 8 protons, 8 electrons, and also 8 neutrons. Bear with me, I'm just trying to shorten things. And here we have 8 protons as well, 8 electrons as well, and in this case you have 9 neutrons. And here in this case now you now have 8 protons, you have 8 electrons, and you also have 10 neutrons. So now here's how it works. Usually the number of protons is equal to the number of electrons, like we all know in basic science. So we're having 8, 8. But like we said, each particular each particular component of the nuclei has two properties. It has its electronic properties and it has its magnetic properties. Electronically, the proton is positively charged, the electron is negatively charged, and the neutron is neutrally charged. But now, magnetically, when you talk about its magnetic properties, the protons and the neutrons they reside from the atomic model that was given to us. Protons and neutrons reside inside the nucleus, then electrons live in the outermost orbitals of the shell. Just like what we said, I'm just going to give a short picture to define this. P and N, that is the protons and the neutrons, they live inside the nucleus. Then the electrons live on the outermost part, as you can see in this picture. Since the electrons are outside and the protons and neutrons are inside, there must be a way to balance the charges. Usually, electrons are like the gatesmen or like the guards that helps to secure the house of the nucleus. Then if the creme de la creme of society are found inside the nucleus, the protons and the neutrons are there. Magnetically, the proton has its own spin, the neutron has its own spin, and likewise the electron too has its own spin. Like we all know, electrons move around along a particular orbital. Protons too also move around along a particular orbital inside the nucleus, and the process of this motion is called precessional motion. So for electrons, they have electronic motion outside. Then for the protons, they have precessional motion inside. And the neutrons are also supposed to be there to balance the spin of the protons. So now, in this case, we have 8 protons and 8 neutrons. 8 protons moving their own spin, 8 neutrons balancing the spin. Is neutral at the end of the day. In oxygen 17, you're having 8 protons and 9 neutrons. So there is still one extra proton, there's still one extra neutron that does not account for any proton. That neutron is the person that gives rise to the extra magnetic spin that oxygen 17 experiences. So for this oxygen, for oxygen 16, there is no spin because everything is balanced. Then for this particular oxygen 17, there is a spin because it is 9 against 8. So there is one spin. Then for this other case, you're having 10 minus 8 and you're having 2. Because it is 2, it balances out. So for this case as well, there's also what? No spin experienced. I hope with this you can understand why some nuclei have spin and some don't have spin. You can do this for oxygen, you can do this for carbon, you can do this for hydrogen. Common nuclei that can be found in organic compounds, you can do this for a lot of them. And you will see this particular pattern working again and again and again.